Ma chambre a la forme d'une cage. Le soleil passe son bras par la fenêtre. Les chasseurs à ma porte comme les petits soldats qui veulent me prendre. Je ne veux pas travailler, je ne veux pas déjeuner, je veux seulement oublier et puis je fume. Déjà j'ai...
Now that you mentioned paraconsistent logics, one obstacle to dialetheiasm is the principle that from a contradiction everything follows, ex contraditione quodlibet. This is a classical logic validates it. It's very counterintuitive, I suppose. Could you tell us where this principle comes from? It seems like the classics didn't realize that the principle followed, or even thought that the principle didn't actually hold. Could you tell us a brief history of this principle and what can be done, what has been done to open the way?
Sure. Okay. So you mentioned this principle, everything follows from a contradiction. Mm-hmm. Its medieval name is ex falso quodlibet, from a falsity, everything, or ex falso quodlibet sequitur, everything follows from a falsity, but they meant a logical falsity. Usually nowadays it goes by a slightly more colourful name called explosion, because what it's telling you is that once you've got inconsistent information or an inconsistent theory, everything follows. So information becomes total. You've got everything, so that your information explodes, as it were. So just to give you, some examples of ex falso quodlibet, there are things like if I'm locked down in New York and I'm not locked down in New York, then Donald Trump is the wisest president that the United States has ever had. That he's the most stupid president the United States ever had. That the moon is made of green cheese. That Donald Trump is actually a pig in disguise. Everything follows, right? Mm-hmm. And your immediate reaction is, hey, there's no connection, right? And at least principle of inference, it seems, should have some connection between premises and conclusions. Mm-hmm. So as you say, I mean, it's highly counterintuitive, although it is orthodox in contemporary logic. Mm-hmm. It's if you've ever taught a first-year class in logic, as I have, and some of people listening will have, this is not a surprise. If you do a sort of a quiz with your students mm-hmm. at the start of the semester, and you give them a bunch of principles of inference, like modus ponens or disjunction introduction or whatever. If you really just don't understand those terms, it doesn't really matter. If you've got explosion on the list, then almost certainly they'll say, no, that's crazy principle. Okay, by the end of the semester, and you sort of hammered them over the head with an introductory textbook of logic, they'll say, yeah, of course it's valid. Mm-hmm. But nonetheless, intuitively, it's very counterintuitive. All right, so that's the principle itself. Now, the principle of explosion is orthodox in the kind of standard logic of our day, which is called classical logic. And we come back to that in a second. Mm-hmm. Logical systems where explosion is not valid are called paraconsistent. And there are many, many of these. They started to be developed around the 1960s in a number of different places, indeed different continents. The first modern paraconsistent logic probably goes to a guy called Jaśkowski in Poland. There's another one produced by Senjo in Brazil, in Argentina. And the first main flourishing of a school of paraconsistent logic was around Newton da Costa in Sao Paulo. Mm-hmm. as I said, Brazil has been a major player in this game ever since the 1960s. But then the ideas were developed also by some Canadian logicians, some American logicians. So it seems to be an idea that has occurred to a number of people independently at about the same time, which is, not unheard of in the history of ideas. Okay, so now we know what paraconsistent logic is. It's a logic where explosion fails. So again, it's taken me a while to get around to your question. Apologies for that, but let me address your question at last. Because explosion is valid in classical logic, you may well think that it's a really ancient principle. It's classical. It must be subscribed to by the Greeks, Babylonians, the Chinese, all the great ancient civilizations. Okay. And the kind of shock is that this is not the case. In fact, explosion has not been orthodox in the history of Western logic. So the situation concerning paraconsistency and the situation concerning dialetheism are really quite different. Mm-hmm. The principle of non-contradiction has been high orthodoxy, explosion has not been. So let me justify that claim. Mm-hmm. The earliest systems of logic go back to Aristotle, and you find his system in the prior Analytics. It's called syllogistic. And this is paraconsistent. And we know this because Aristotle himself points this out. He says, look, take contradictions, then they'll imply certain conclusions in some moods of the syllogism, but not others. So he says that, hey, in some moods of the syllogisms, contradictions don't imply anything. So if they don't imply anything, they don't imply everything. In fact, 40 euro, they don't imply every contradiction. Okay. So Aristotle is clear that his system of logic, explosive, is paraconsistent. It's not a modern system of logic, but it satisfies the defining condition. Now, there's another system of logic that appears at about the same time in the history of Western philosophy. Eastern philosophy is another subject. I mean, we can talk about that on another occasion if you want to. But let's just stick to Western philosophy and Western logic for the moment. Mm-hmm. So about the same time that Aristotle is working, the Stoics in a suburb of Athens are also producing a system of logic. In modern terms, in modern terms, there's a distinction between first order logic with quantifiers and propositional logic, which only has connectors like and, or, not. Mm. And syllogistic is an early version of quantifier logic, whereas what the Stoics are producing is a version of propositional logic. And the medievals inherit both, and they try to put both together, and that's another story. But these two systems of logic are kind of coeval in ancient Greece. Mm-hmm. Syllogistic is paraconsistent. As far as we know, the Stoic logic was also paraconsistent. That's a bit more conjectural because we know less about Stoic logic. The original texts haven't survived. Mm. So what we know about Stoic logic is mainly in fragments and commentaries from later people. But they don't no one ever says that the Stoics endorsed explosion. And a lot of the sources that report Stoic logic are hostile to Stoic logic. So the skeptics are incredibly hostile to the Stoics. Mm-hmm. And one of the best accounts of Stoic logic comes from Sextus Empiricus, who's a big skeptic, and he has a lot of gripes about Stoic logic. If the Stoics had endorsed explosion, you'd have expected to say, hey guys, look, they endorse this crazy principle. What do you expect? So as far as we can tell, Stoic logic does not endorse explosion either. All right, so where does explosion come from in the history of Western logic? Well, again, to a certain extent, we have to be conjectural because we don't, I mean, there are many texts in the history of logic we don't have. But the first recorded appearance seems to be in about the 12th century. So there's a medieval philosopher called Admiral Bolsham, who's working in Paris. And his group is called the Paraconsists, presumably because they lived by a small bridge on the Seine. And one of the group is called William, who presumably came from Soissons because he's called William of Soissons. Mm-hmm. And he invented what's known as William's machine. And William's machine appears to have been an argument for explosion. It's a very simple argument. It's an argument that's been rediscovered at various times by different people. Mm-hmm. But he gives an argument for explosion. And from that point on, it's on the agenda of logicians, shall we say. Okay, so let me pick up the historical story in a second, but let me tell you what William's argument was, because it's kind of simple and it's very natural. And it goes like this. Suppose you've got a contradiction. So you've got A, and you've got A is not the case. It's what logicians call not A, right? A and it's not the case today, A and not A. Well, look, if A is the case, then presumably for any B you like, either A or B is true. You know, if it's snowing, well, it's either snowing or raining. Okay? If it's snowing, it's either snowing or the sun's shining. You know, if A is true, then for a disjunction, A or B to be true, one of the disjuncts has to be true. Mm-hmm. And so if one of the disjuncts is true, both are. But the disjunction is, so if A is true, A or B is true. Okay, so logicians call that disjunction introduction. Okay, so where have we got to? We've got A, so A or B, whatever B you like. Mm-hmm. But hey, you've got not A as well. And not A rules out A. So if you've got A or B and not A, it must be B. Therefore B. Mm-hmm. Okay? So you've inferred this arbitrary B just from A and not A. Mm-hmm. So this was what we think William's machine was. And you find it in a number of medieval philosophers such as Scotus. It's independently rediscovered by C.I. Lewis at the beginning of the 20th century. And it's that argument which really puts explosion into play in medieval logic. Now, the status of explosion in medieval logic is a bit contentious. One thing the scholastics are doing, very good at doing, is drawing distinctions, as are modern logicians for that matter. Mm-hmm. And they tend to draw distinctions between different kinds of validity, formal validity, material validity, and they don't even, or different logicians define those terms in different ways just to make matters complicated. But it's not uncommon to find logicians saying, well, it's valid in one sense, it's not valid in another sense. Mm-hmm. It's at least a principle that's debated, and different medieval logicians go different ways on the debate. So it's at least there in discussions in medieval logic. What happens after that? Well, around the 15th, 16th centuries, you get the rise of humanism in Europe. And with the rise of humanism, scholasticism, medieval scholasticism, gets wiped out. It survives a bit in the Catholic Church because of Aquinas, but Aquinas isn't really a logician. And so all the fantastic advances of medieval logic, all the works of the great medieval logicians like Scotus, like Burdon, like Occam, are pretty much lost. And it's really only in the 20th century we started to rediscover some of this stuff. Mm-hmm. But anyway, you know, all the advances of medieval logic are lost. And all that remains is people still know their Aristotle, and they know a little bit of the terminology of medieval logic. They'll know what modus ponens means, for example. That's obviously medieval because it's Latin. Mm-hmm. But essentially, if you look at logic texts of the 17th century, what you get is Aristotelian syllogistic with a few frills.
Mm-hmm.
So logic goes back to being paraconsistent. And that situation remains until the end of the 19th century. So things change at the end of the 19th century, but you can see we've covered a period from, say, 400, 500 BCE to the end of the second millennium. And for most of that period, explosion was not accepted. So that's what I meant when I said that in the history of Western logic, it has not been an orthodox principle. Okay, so things change at the start of the...
Out of curiosity, is there any other independent way to prove classically the principle without using addition or without using a disjunction introduction?
Yes.
So disjunction introduction is not really the culprit, necessarily the culprit.
No. No, I mean, you can do a bunch of things. So, for example, you can reframe the argument using and instead of or. It employs slightly different principles, but there's a conjunctive version that works.
Okay.
There's another argument you can run which uses the principle of identity. Okay, now the principle of identity is something you might want to talk about. But essentially, the principle of identity says if A, then A. If it's knowing, it's knowing. Okay, if you have certain understandings of the conditional of what if means, then you can also wring the principle of explosion out of it. So there are other arguments you can give, but that argument, Williams' machine argument, is really the one that has sort of stuck just because it depends on two principles of inference. Essentially, one is that if A, then A or B, and one is that if A or B, but not A, then B. And those look pretty persuasive. Okay.
Yeah.
The second incident, incidentally, is sometimes called the disjunctive syllogism. It also has a cooler medieval name, but most people call it the disjunctive syllogism. And both those principles or introduction of the disjunctive syllogism look pretty persuasive.
Yeah.
And so, that's one of the things that I think has pushed explosion into orthodox. Not the only thing, but it's one thing. Mm-hmm. Okay, so back to history. That takes us to about the end of the 19th century. And in the end of the 19th century is a fantastic time in logic. Mathematics has developed to a point where mathematical techniques, sophisticated techniques, can be applied to logic really for the first time. Leibniz had a go at it, but the mathematics of his day wasn't really up to it. But by the end of the 19th century, you've got fantastic advances in algebra, independent results in geometry, a drive for rigor. And so the mathematicians at the end of the 19th century can start to apply these techniques to an analysis of logic. And probably the most important person here in retrospect is the German logician Gottlob Frege, closely followed by the British mathematician Bertrand Russell. And they had a philosophical agenda in the philosophy of mathematics. So at the start of the 19th century, there was this whole menagerie of numbers, complex numbers, infinitesimal, rational numbers, real numbers. And then by the end of the 19th century, you've got infinite numbers too to play with. And people didn't really understand how they all worked. And what you see in the 19th century is progress. In the end, by the end of the 19th century, all the other kinds of numbers have been reduced to whole numbers, 0, 1, 2, 3, 4, plus a bunch of constructions of sets of these. Actually, some have disappeared, like infinitesimals, but that's another story. So by the end of the 19th century, mathematicians had a pretty good grasp on what all the other numbers were. They didn't know what the whole numbers were. And so Frege and Russell, a bit later, had this philosophical thesis, namely that if you just spell out your principles of how sets behave, you can actually define whole numbers in terms of certain sets. So in the end, everything gets reduced to set theory, and Russell and Frege took set theory itself to be a part of logic. And so they thought that all of mathematics was reducible to logic. This is logicism. Mm-hmm. Okay. So they needed to establish their thesis. And what they needed was a bunch of principles concerning sets, and then they wanted to be able to deduce all the stuff about numbers rigorously. So they needed a canon of inference to do this. And the logic of the day was not up to this. You couldn't do it in syllogistic. Mm-hmm. So what they did was invent this new canon of inference. And for better or for worse, it's got to be called classical logic. It's got nothing to do with the classical civilizations of antiquity. That should now be obvious. And I don't think the term classical logic was coined until probably the 1920s. And it was coined in the context of the debate between people who believed in the principle excluding middle and people who didn't, the intuitionists. But that's again another story. Anyway, so Frege and Russell designed this new canon of inference, which would do the trick. It allowed them to make all the mathematical deductions that they felt they wanted. And the power of this new canon of inference was so, it was so much better than what had gone before, that it soon became orthodox. By the 1920s, 1930s, there wasn't really a serious logician who would have rejected it. I mean, there was a sort of background reaction from some of the traditionalists, some of the Thomists, for example. But within a very short space of time, it had kind of won the day quite clearly. And until, no, that's not true either. I mean, the problems of classical logic were evident right from the start. So the first people who object to classical logic are people like the intuitionists and C.I. Lewis, who we mentioned just now. So the backlash, or at least the critics of classical logic, start to appear, So Principia Mathematica, Russell's book, is published in 1910, the first volume, and the critics are already busy at work in 1910, 1920. But classical logic looks so good that few people take these problems seriously. And what you get around the 1960s, 1970s is a realization that the kind of mathematical techniques that allowed Frege and Russell to construct classical logic do not have to deliver classical logic. They're very, very general techniques. So mathematical logic does not have to be identified with classical logic. And so what you get in the 60s and 70s is this amazing realization, hey, that we can construct other theories of validity using these very powerful mathematical techniques. So this is when the serious investigation of non-classical logic kicks off in the West. At least, let's leave it at that. And paraconsistent logic, in its modern sense, Jastrowski, Da Costa, and company, they're part of this movement of the development of non-classical logic. So paraconsistent logic is one kind of non-classical logic. There are lots of other kinds. So explosion became really entrenched in logic around the turn of the 20th century, and it's still the orthodox logic of our day. If you're a student and you go and do Logic 100 at some university, you'll be taught classical logic. Mm-hmm. In that sense, it's orthodox. But at least for the last 50, 60, 70 years, there's been this whole swag of non-classical logics, and philosophers and logicians have argued about which of these systems might be the correct logic, and indeed what that could possibly mean. What does it mean to say that something is a correct logic? So All right. So your original question was about the history of explosion.
Yeah.
And at greater length than I really intended, I've told you about it.
Okay, thank you very much.